Hello everyone. In this video we will discuss about the trending question, that is the number of relations. So number of relation is a trending question nowadays. Every year NTA is asking a question, a simple question on number of relations. If you know the formula, you can give the answer immediately and you can score 4 marks very quickly. So what varieties of question they are asking? I have written down these 7 varieties of questions nowadays they are asking, any one of them. First one is total number of relation, second one is number of reflexive relation, third one is number of symmetric relation, fourth one is number of relation which are both symmetric and reflexive, fifth one is number of relation which are symmetric but not reflexive, and sixth one is number of relation which are either symmetric or reflexive, and finally number of equivalence relations. So in these 7 varieties of questions you can score 4 marks very easily. Okay, so let's start with the, say, if let A is any set containing n elements, okay, that is order of A is n and R is defined from A to A. R is a relation defined from A to A. Okay, fine. Then we have to find out the total number of relation. We know that R is a subset of A cross A. Okay, and A cross A contains how many elements? This contains n square elements. Okay, because A contains n elements, therefore A cross A contains n square elements. Okay, and every subset of A cross A is a relation. Therefore, total number of relation we can have as 2 की power n square. So first question is over. This is 2 की power n square. Now you have to remember this. That is the total number of relation defined on the set A is 2 की power n square, where n is the order of the set A. Fine. First question is over. Now coming to the second question. Second question is total number of reflexive relation. Now total number of reflexive relation we will find out by using the concept of permutation and combination. Okay. See, A cross A contains n square order pair elements. That is like that 1 comma 1, 1 comma 2, like that order pair elements A cross A contains. These n square ordered pair elements we can plot in terms of the matrix. See, this is the matrix having n rows and n columns. So therefore all the n square ordered pair elements we can plot over here like that 1 1, 1 2, 1 3, 1 n, 2 1, 2 2, 2 3, 2 n, like that n 1, n 2, n 3, n. Okay, this is the concept. Now see, these are the diagonal elements. 1 1, 2 2, 3 3, n are diagonal elements. So total diagonal elements definitely there will be n total diagonal elements and total non-diagonal elements that will be n square minus ka n. So these elements plus these elements is n square minus n. So therefore half of this is n square minus n by 2, and these are n square minus n by 2. So how many number of elements? That is order pair elements. They are above the diagonal elements. Same number of elements we are having below the diagonal elements. And one important point is that this diagonal will be the measure for this 1 2 and 2n. 1 2 and 2 1 are image of each other about this diagonal, correct? Okay, fine. Now we have to find out the number of reflexive relation. Number of reflexive relation, it means that this 1 1, 2 2, 3 3, 4 4 and n has to be present there. There only we can say that the relation is a reflexive relation, otherwise not. But apart from this 1 1, 2 2, 3 3, this 1, 2 can be there. It can be there, it cannot be there. No problem with that. Okay, the relation is still reflexive relation because all these diagonal elements are already present. Apart from these diagonal elements, if 1, 2, 1, 3 or any other non-diagonal elements is there, then still the relation is reflexive. So here comes the concept of permutation and combination, that this 1, 1 has one choice only. How to calculate the total number of reflexive relation? 1, 1 has only one choice, correct? 2, 2 has only one choice. All the diagonal elements has one choice. How many diagonal elements? N diagonal elements. So this is 1, 1, 1 into 1 into 1 up to the n times. And what about these non-diagonal elements? Every 9 diagonal elements has two choices. Either they will go or they will not go. Still the relation is reflexive because all the diagonal elements are already present there. So therefore, according to the principle of counting, okay, this is 2 for 1, 2. This is 2 ways for 1, 3, and similarly 2 ways up to the how many times? Up to the n square minus n. N square minus n. All these plus these are n square minus n. So n square minus n. So therefore the total number of reflexive relation you can find out as a 2 p power n square minus n. This becomes the formula for total number of reflexive relation. What is the formula? 2 p power n square minus n. So you have to remember this 2 p power n square minus n as a formula. Okay. Now coming to the next question, that is the number of symmetric relation. Now symmetric relation. See, for symmetric relation, if an order pair A comma B is there, then B comma A should be also there. Then only we can say that the relation is symmetric relation. Okay. Now how to find out the total number of symmetric relation? See, if 1 comma 2 is going to the relation and relation is symmetric, it means that 2 comma 1 is also there. That is 2 comma 1 is depending upon 1 comma 2 for the relation to be symmetric. So it has no choice. Only 1 comma 2 has the choice. 1 comma 2 either go to the relation or will not go to the relation. So 1 comma 2 has two choice. And according to that, it depends on, this 2 comma 1 depends on 1 comma 2. So we will either find out the number of ways of going to the subsets of A cross A for the elements which are above of the diagonal elements or below of the diagonal elements. The below diagonal elements depends on above and above diagonal elements depends on below. So therefore, this 1 comma 2 has two choice. This 1 comma 3 has two choice. And like that, we are having how many elements above the diagonal? N square minus n by 2 times. Correct? So this is for the elements which are above the diagonal elements. So they have only one choice. If 1 comma 2 is going, then automatically 2 comma 1 has to go there. So therefore no worry to calculate the, okay, like that. So now coming to the diagonal elements. Also diagonal elements 1 comma 1, if going to this set which is to be symmetric, then no problem, no? 1 comma 1, then 1 comma 1. So A comma A already there. That means that A comma A is present there. So therefore the relation is still symmetric if 1 comma 1 is going or 1 comma 1 is not going. So therefore every diagonal elements also has two choice. How many diagonal elements? There are n diagonal elements. So finally we have 2 ki power n square minus n by 2 into 2 ki power n. Finally this is 2 ki power n square minus n by 2 plus chi n. When we simplify, this will become n square plus n by 2. That is the total number of symmetric relation. 2 ki power n square plus n by 2. This is 2 ki power n square minus n. This is 2 ki power n square. This is 2 ki power n square plus n by 2. Okay. So this is the total number of symmetric relation. Now coming to the relation which are both symmetric and reflexive. So the relation is already reflexive. That means this diagonal elements 1 comma 1, 2 comma 2, 2 comma 3, 3 comma 3, all these have only one choice because the relation is symmetric, means they have to be present there. Okay, all the diagonal elements. So therefore we are having, this is what, 1 comma 1 into 1 into 1 up to n times. This is for reflexive relation, and the relation has to be symmetric also, both reflexive and symmetric. For symmetric, definitely 1 comma 2 has two choices like that. So 2 into 2 into 2 up to the n square minus n by 2 times, because 1 comma 2 is present or 1 comma 2 is going, that means 2 comma 1 has to go there, correct? So that the relation become symmetric. And one important point is that in this symmetric relation, the relation is also reflexive, that is 1 comma 1, 2 comma 2, 3 comma 3 are already present there. So now total number of relation which are both symmetric and reflexive is 2 की power n square minus n by 2. This is the formula, 2 की power. So this is what? This is 2 की power n square minus n by 2. So this formula you have to now remember. This is 2 की power n square plus n by 2. That is for symmetric relation. For symmetric and reflexive, 2 की power n square minus n by 2. For reflexive relation, 2 की power n square minus n. And for total number of relation, 2 की power n square n. And the relation R is defined on the set A, and set A containing n distinct elements. Okay, this problem is also over. Now this fifth and sixth question you can answer directly on the basis of these number of relation. The number of relation which are symmetric but not reflexive. Either that symmetric but not reflexive. Not reflexive means this 1 1 2 2 3 3 and n should not be there. If they are present, then the relation is not reflexive. Okay, we don't want, then the relation is reflexive. We don't want the relation to be reflexive but symmetric only. So how? The total number of symmetric relation is 2 की power n square plus n by 2 and then minus 2 की power n square minus n by 2. That is the symmetric relation. Okay, and minus the relation which are both symmetric and reflexive, correct? The relation which are both symmetric and reflexive. So this is interesting. 2 की power n square plus n by 2 is the total number of symmetric relation, and 2 की power n square minus n by 2 is the number of relation which are both symmetric and reflexive. But I want the relation which are only symmetric, not reflexive. I want the relation which are only symmetric, not reflexive. Therefore this is the formula, correct? Fine. So this formula you are having here. What is that? This is 2 की power n square plus n by 2 minus 2 की power n square minus n by 2. And finally here use the A union B concept, the number of relation which are either symmetric or reflexive. That is n of R union S. That is n of R plus n of S minus n of R intersection S. N of R means 2 की power n square minus n. N of S is 2 की power n square plus n divided by 2. And R intersection, both symmetric and reflexive, is 2 की power n square minus n by 2. So these are the number of relation which are either symmetric or reflexive. Okay, and then finally we will discuss about the number of equivalence relation, how to find out the number of equivalence relation. There is a shortcut, but before that we will solve an example, okay, so that we can find out all these kinds of relation. They will ask anyone, and on the basis of these formulas only you can answer. For example, let A is containing A, B and C. These are the three elements. That is n of A is 3. That is n is 3. The first question is total number of relation. Okay, I am asking in an order. First question, total number of relation is 2 की power n square, that is 2 की power 3 का square, that is 2 की power 9. Second question is total number of reflexive relation, that is 2 की power n square plus reflexive relation n square minus n. Okay, so 3 square 9, 9 minus 3 6, that is 2 की power 6. Third question is total number of symmetric relation. What is the formula? 2 की power n square plus n by 2. 3 square 9, 9 plus 3 12, 12 divided by 2 6, again 2 की power 6. Okay, and fourth one is total number of relation which are both symmetric and reflexive. So what is the formula? 2 की power n square minus n by 2. So 3 square 9, 9 minus 3 6, 6 divided by 2 3, that is 2 की power 3. Okay, now coming to this one, this is interesting, important. Okay, the number of relations which are symmetric but not reflexive. So this formula, symmetric minus symmetric and reflexive. Symmetric and reflexive. Symmetric means this one, this is symmetric and reflexive. So that is 2 की power, fifth one is 2 की power 6 minus 2 की power 3. And finally we have come to this question, number of relations which are either symmetric or reflexive. That is, this answer is, here I am writing, n of r union s is total number of reflexive. What is that? 2 की power 6 plus total number of symmetric. What is that? 2 की power 6 minus total number of relations which are symmetric and reflexive both. That is 2 की power n square minus n by 2. That is 9 minus 3, 6, 2 की power 3. So this is your answer. Correct? Okay, fine. So this is all about the number of relation. Now coming to the number of equivalence relation. Equivalence relation, you have to understand the shortcut process. See, for equivalence relation, what we will do? First write down 1 here and 1 here. Okay? Correct? Okay. Then from here we will move onward, 1 here and add these two. Write down this as a 2 over here. From here we will move forward, 1 here, 2 here. Okay. Now bring this 2 over here. Okay. Here we are bringing 2. Then add this 2. This is 2 plus 1, 3. Add this 2. 2 plus 3, that is 5. Correct? Again this 5 will come here. So this is 1, 1, 2, 2, 3, 5. 5 is coming here. Correct? So this is now add 5 plus 2, 7, 7 plus 3, 10, 10 plus 5, 15. Same way again 15 will come here. So this is 1, 1, 2, okay, 2, 3, 5, then 5, 7, 10 and 15, and then 15 will come over here. So 15, 15 plus 5 is 20, 20 plus 7 is 27, 27 plus 10 is 37, 37 plus 15 is 52. Now, look at here, total number of relation. This 1 is the total number of relation. This is total number of equivalence relation when n of a is equal to 1. This 2 is the total number of equivalence relation when n of a equal to 2. This 5 is the total number of equivalence relation when n of a is equal to 3. This 15 is the total number of relation when n of a is equal to 4. And this 52 is the total number of relation when n of a is equal to 5. And therefore you can also calculate the total number of relation when n of a is 6 in that process, n of a is 7 in that process. I hope that you understand the way we have calculated by this way the number of equivalence relation.